I'm joined by Dylan Payne, the Predictive Maintenance Supervisor for the Phillips 66 Midstream Center of Excellence, and with Kishore Manganani, the co-founder and CEO of Shoreline AI. Can I get you to elaborate on just kind of what the challenges y'all have been facing in the midstream sector are when it comes to data and monitoring?
So, the biggest challenge, especially in midstream, when you have equipment that's just so far away, sometimes it can take hours to get to some of these locations. And when we're doing our routine vibration analysis or sending a person out there, they can spend a whole day just driving to location, doing the vibration analysis, and then driving back. And sometimes they don't even get to analyze the data in the same day because of just the drive time alone. So having a solution out there to where it's already at location and can be pulling that data for you, not only once a day, but several times a day. So you have different data sets throughout the day, because conditions do change. That's a different way of working and a way to improve your efficiencies and help improve your reliability as well.
What we found was, you got to make sure the connectivity is easy. So the end user who's going to install is not an IT expert, is going to be a field technician. Okay, make it easy to connect. A lot of machines are not connected, data is not available. Second thing is, once you connect and get the data, well, what should be monitored? Okay, you don't need to have experts to configure each machine. That's how it's done today before the Shoreline solution. And the third thing was time to value. How quickly you can start predicting failures, predictions, not like, I need 6 months of training or 1 year of training.
From your perspective, just curious, what challenges do the midstream sector bring as opposed to other industries you've worked with?
First thing, these are big machines. These are not small motors or pumps. These are compressors, probably the size of this area, correct? Second thing is, these things are at remote locations. You have, a lot of sites have no broadband connectivity. A lot of sites, the closest cell tower is 25 miles away. Okay, so you got a connectivity issues. Then these machines are very big, so high temperature, difficult environment. So environment is very difficult in terms of to be able to monitor. On top of that, to bring all the data easily in the cloud without having to send army of experts on these remote sites, I would say that's one of the largest challenges. Unlike a lot of other machines, pumps and motors, there's not a lot of data historical available on these machines. So you have to build models, pre-built models, which can deliver value within the first few weeks, not takes another year. Here, you cannot generate false alarms. People have to travel 3 hours to go monitor and fix things. So you got to be very accurate in your analytics and predictive maintenance alarms. And I think that means accuracy has to be very high. What do you think? What else?
I think you hit the nail on the head right there.